Good morning, everybody, and welcome to episode 19 of MakerBot Chats. My name is Felipe, Creative Director at MakerBot, and welcome once again to our space here, joined by, of course, as usual, Method X, Sketch. And just, a quick reminder of what this is. Basically, an open forum for you guys to ask us questions on new materials, how to use the printers, where we get to introduce also like new technologies or new platforms, and in this case, materials, as I said earlier today. So, as you may have heard, last week we launched a new set of Polymaker materials compatible with MakerBot LABS. We'll be talking about that. We'll be talking about also what is MakerBot LABS, how to use it, how to use the LABS extruder. And I have a few sample prints as well here. But yeah, as usual, let us know if you have any questions. There's that chat window on the top right corner of your window. And Alejandra, who is behind the scenes managing everything, she'll be able to communicate the questions to me, and we'll try our best to answer as many of them. If not right now, we'll answer them through email. So with that, yeah, let's get started. So, pretty exciting news every time that we introduce new materials. This time we're talking about polycarbonate materials. Polycarbonate, it's a really interesting thermoplastic. It tends to have a higher melting temperature. It also tends to be super stiff. I have a few samples here with me, and specifically we introduced three materials. PolyLite, which is what I got here, great for semi-translucent applications, very clear material, impressively smooth. Then we also have regular polycarbonate, and it used to be PC Plus, now they call it PolyLite PC. And then we also have Polymax PCFR, so that's fire retardant, and we'll be talking about the specifics of each of them, what are the main applications, and what's the deal with them. So let's start with PC-PBT. Interesting. So I don't have, let me fade here. So PC-PBT, and I'm sorry about the camera here. I have a few, actually, the box that I have on the floor is not PC-PBT. It's actually PCFR. Here we go. All right, much better. So what we got here is two things, in this setup. Box one, I have the LABS extruder. I'm going to show you what that is, how it looks like, how it comes. But first off, I'm going to start with the Polymaker material. Just a quick review. As you can see in the picture on my, your guys' left, it's black filament. It's, directly from Polymaker. It comes in this really nice box packaging. Quick intro to the material itself. Also in the packaging, just a quick overview of the applications, the best ways to print it. And one of the reasons why you really need to print it in something like Method is that these materials are very sensitive to heat. So they need higher temperatures to be printed at. Specifically, they need a heated chamber, right? And not every printer, it's very rare for printers until 20,000. As far as I know, like real heated chamber, only Method offers that, specifically Method X, because you have to take that chamber up to 110 degrees Celsius. Yeah, it's just hard to get in any printer that is under $20,000. So it comes with a quick brochure, then the filament neatly packaged. Of course, I've already opened it, but it comes in this, we call them space bags, but it's just a Mylar bag that keeps the material free of moisture. The bag itself has, of course, a Ziploc of sorts here, and inside of the bag, of course, the filament. What I like a lot about what Polymaker does with their materials is that they actually list out the settings of the material every time, in every material that you get. I'll try to bring it closer to the camera, but you can see how it's saying the print speed, the print temperature, maybe a little bit further away so that the camera can focus on it. Here we go. The print temperature, the bed temperature, and of course the bed temperature here, it actually implies the heated chamber, because if you don't have a heated chamber and you're trying to print something larger or like not necessarily flat or that goes like let's say more than a 1/4 inch away from that build plate, you're going to struggle quite a bit. It's going to be really hard for you to actually control that material as you print. So great packaging, simple process. Also, of course, it comes with a desiccant bag. Always try to keep them in there. It really helps keep your materials dry. Some of these materials are fairly sensitive to humidity changes, so it's important to keep that in mind. And yeah, well, with PCFR, the whole deal of it is that it's actually fire retardant. It will have a slightly higher melting temperature, and we can go right now into the specifications. Let me just bring that over. Just need to change some things here. Give me 1 second. Here we go. PCFR. Sorry about that, just technical difficulties here. All right, here we go. So here's Polymaker's website. Let's just go quickly through the technical specifications for PCFR, right? As you can see, the nozzle temperature tends to be a little bit higher, somewhere between 250 to 270. I have been printing with 260. I think that's kind of a nice in between, and it's been working okay. The print speed I didn't mess up with too much, basically 30 millimeters per second. The chamber temperature, this is what I was talking about, right? If you're printing something very small, you might get away with printing it on with a printer that only offers a heated build plate. However, for real applications, like I have, where is it? Kind of like this fan right here. As soon as you go like a 1/4 inch away from that build plate, it's going to be really hard for you to actually control the print and get proper results, right? So you do need a heated chamber, only something like what Method and specifically Method X offers, because you're asked, right, and required to have somewhere between 90 and 100 degrees Celsius. I've been printing it with 110. It actually helps a lot with the material. It keeps it warm and happy, and basically guarantees that you get the results that you're expecting. Now, on the bed surface, I think it can be a little bit tricky to manage. We've seen some results where the bed itself gets a little bit dinged, after printing a few times. So far, it hasn't been so bad. You can see how, like here, some of the bed itself has been damaged because of the removal process. That's because of the higher temperature and how much the polycarbonate materials want to adhere to that build plate. So just keep that in mind, right? You might need to update your build surface a little bit more often than you regularly would for, like, let's say ABS or ASA materials, like lighter temperature thermoplastics. But it's not too bad. I would say, like, easily you can have like a good 20-30 runs with the build tape, and you should be fine, right? It all depends on how aggressive you are when removing the material itself. Now, let's go to the second material that I have here. So PC-PBT, I'll just do a quick intro here with the image that you can see on the left-hand side. We printed a rear view mirror. I don't have it here. We actually sent it over to the office to get some better pictures of it. But I'll just talk about it on Polymaker site. That might be easier for all of us. So again, going into the specific technical specifications of the second material, so PC-PBT, right? It's actually really tough. It's so incredibly stiff. That was one of the first things that I discovered when I started printing with it. It's really stiff of a material. It doesn't want to bend, so it's great for applications such as things that might be exposed to lower temperatures, or also a little bit of chemical resistance, and what that means maybe outdoors applications such as like the rear view mirror that I was showing you guys. That's an example from Polymakers themselves. And again, the nozzle temperature stays a little bit hot. It goes a little bit hotter than what we had with PCFR, so 260 to 280. Print speed stays the same, but the chamber temperature increases a little bit, right? From 90, now it goes to 100 C to 110 C. I have been maxing out the print temperature in Method because it actually helps a lot with preventing warping, right? Especially if you're having larger prints, they will want to warp with this material. It's really sensitive to temperature changes, so you really want to have that super hot environment where the material will be happy, you'll be able to print it okay, and you'll get ultimately the results that you expect, right? So fairly high tensile strength, fairly high bending strength, so 41, well, Young modulus, about 2000 megapascals, tensile strength about 42, and then the bending strength, which stands at 64, almost 60, 64 and a half. Again, it's a really tough material, incredibly stiff, so for applications that might require, you know, something to withstand either some chemical weathering, some outdoor use, that just need to be like, you know, like the blades in this fan. We printed this fan actually in many different materials. I think that PC-PBT is one of the best applications of it. Oh, and speaking about it, like on the support side, so how do you print supports with these materials? You have two options. You can either do it with breakaway supports, or in Method's case, you do have the option of soluble supports for polycarbonate materials. Specifically, what we use are SR30 supports. Those are soluble supports. They come directly from our partner company, Stratasys. Super efficient and kind of like a no-brainer. It's specifically great to have, you know, such a technical material, but you are still able to use soluble supports. That's also one of the things that other desktop settings might not offer, right? If you think about more entry-level printers, let's say printers that only have heated build plate and do not have soluble supports for higher temperature thermoplastics, you're going to struggle a lot, especially when printing more complex parts, right? Let's jump now directly to the third and last material we've introduced. So here we go, the PolyLite PC. This one is like, I think it's one of my, probably my favorite of the three. Super easy to print with. It's a little bit, I would say, a little bit less sensitive. Let's see if that's true on the technical aspects. I really don't remember. But less sensitive to temperature changes, but the results are just amazing, right? It's like the clarity that you get with the material itself. It's really great. You can see on that application there on the left. I'm going to jump right into the technical specs page. Here we go. Okay. So nozzle temperature stays about the same, a little bit lower, goes to 250 to 270. I have been printing all of these with 260 degrees on the nozzle. It's been printing just fine. We're going to probably update those specs also in the Thingiverse group, so you guys can have access to those. The printing speed, around the same, 30 to 50, and the bed temperature, 90 to 150. Here, Polymaker doesn't require the heated chamber. I would say that it does make a tremendous difference, you know, for all of the materials. So seriously, I would consider also using only printing it with a heated chamber, specifically with Method X. At least you do need the bed temperature, so the heated build plate, you know, somewhere between 90 to 105 degrees Celsius. This will prevent your parts from starting to, you know, dance around. But I think that especially like if you're considering something larger that goes away of the, you know, further away from the build plate like this lampshade did, you really do want to have that heated chamber, that control of the environment. Otherwise, your parts are just going to crack, right? It all comes down to the heated build plate, as we've said in the past, guarantees the first couple of layers. As soon as you go away from that build plate, you still need that heating element to guarantee addition between the layers. So if you don't have a heated chamber, then you all but surely are going to be challenging the addition in between the layers, right? So you'll probably get a lot of cracking in the layer. I'm sorry, it's kind of dry here. Cracking between your layers. It's going to compromise your prints, and ultimately it's just going to be a headache. So it might not be required for this one material. I still strongly recommend only printing it with a heated chamber because of that. I've seen it like where you basically touch the part, press it upwards, where, you know, on some of the components that we're not printing up against the heated build plate, and the part just cracks. It just cracks, and it doesn't happen. You know, you have that consistent performance throughout the whole height of the part with a heated chamber. So here, going to the mechanical properties, Young modulus fairly consistent, 2300 megapascals. Tensile strength also about the same, almost 63 megapascals. And then the bending strength, it's a little bit higher here, right? So 100 megapascals for the PolyLite. It's actually a great material. I mean, depending on the application, depending on the shape itself, you can make it be very translucent. If not entirely clear, it will allow light to go through, right? So you can see it here. If I put this against the light, let's see if it works here. No, I need to put the light inside of the shade, but it definitely allows light through. Depending on the number of shells that you're using, depending on the geometry itself, you will see different results. So something to consider here if you're trying to create something translucent, like a lampshade, like something that's going to require some degree of, for it not to be opaque. All right, so these three materials are available now with our labs extruder, right? And just wanted to show you and remind you guys, here we go, what our labs extruder is. So pretty straightforward. The labs extruder allows you to unlock your Method machine. It's a great alternative when buying a Method, just because then you're not necessarily tied to MakerBot's materials. I do believe that the MakerBot materials range, it's quite amazing, especially now that we have the nylon carbon fibers available. But, the labs extruder will allow you to print with whatever it is that your heart desires, right? That includes some of the materials that have been vetted and tested by us, specifically speaking, what I've just talked about, the Polymaker materials. And it's quite a simple system, right? The idea here, and I'll just open this brand new labs extruder, is that you get a new extruder, basically comes in a nice package like so. The extruder is a little bit different than our standard extruder. I'll show it in a second. So this would be our standard extruder. You see how the tip, it's actually covered. In the case of the labs extruder, the tip is exposed, and the reason for that is actually so that you can change the nozzles here, right? The nozzle is also different. You probably can see here in my video. Let me try to get it closer to the camera. Our standard nozzle is a brass nozzle. However, with the labs extruder, you're getting a stainless steel nozzle that is going to be much more resistant to wear and tear. That's because we expect some of the labs material to be a little bit more abrasive. So, we're just setting you up with a stainless steel nozzle. And not only one, in the package itself, you get two nozzles. So you get the nozzle that's in the extruder. You get an extra kit here that has an additional nozzle and these keys that allow you to actually swap the nozzles in and out. So let me get the nozzle out for a second. That's one other thing that most people don't realize, how much more comprehensive the system is. So I don't think that there's that many printers out there that offer such a long nozzle pipe. The reason for that is not only aesthetic, but it's actually because we want to better control the way that the material is heated up. So instead of just having a super short nozzle that immediately saps the material and melts it right away, which can challenge the way that you can control the flow, we actually have a much more even distribution of the heat in the nozzle. Specifically, our nozzle is about 3 times as long. The heated element is about 3 times as long as a standard extruder. And this extended pipe just guarantees that the material is going to be sort of much more evenly flowing through the nozzle, right? So the whole nozzle is in there. You also get a little, let's see, hex key to release the nozzle here. So the nozzle is fixed there with a set screw. So you only remove the set screw and then that releases the nozzle for you to use. So yeah, I think it's a pretty straightforward system. As we've said in the past, this will allow you to load any type of material. It doesn't have to be a MakerBot material. I still recommend using the MakerBot materials. And if you're using labs, then still using some of the materials that we recommend, like the Polymakers, because those materials we have vetted, right? We have tested it out. We have tried the settings and we know that they work. Just trying to save you some time in figuring out, does this material require any extra settings? How do I make it work the best with my method? So again, highly recommend keeping it up with the lab specific materials, but I think it's just a great tool to have, the Labs extruder. So simple box. I think it's about $250 per extruder on the Labs extruder, and then you're basically set to print with whatever material you might want to print with. And sorry, back here to our tech specs, and with that I'm going to start jumping into our questions now. All right, let's see which questions we have. How do you avoid warping and shrinkage of filament? I think that comes down to having the proper temperature settings. As I said before, these materials are really heat demanding, so you really want to keep in mind having a hot environment when printing with it. It's important that, you know, I would max out the temperature in the Method X. That goes to 110 degrees Celsius. And so far, I've been having great results, right? I think that the prints speak for themselves. It's just basically what you need. You need to keep the thermoplastic happy so that it doesn't shrink too fast, and ultimately you get proper results here when printing. Is polycarbonate hygroscopic? Okay. How to keep filament free of moisture? Yes, so you should avoid exposing the filament as much as possible to humidity. I only keep it outside when I'm printing with it. The reason is because you're actually side loading the material on the printer. These spools, the one downside that they have is that since they are not MakerBot spools, they won't fit inside of our drawers. The drawers are there to control the humidity of the material. So since you don't have that, you really want to be conscious about where do you store the material, just keeping the material outside for as little time as possible. That basically means only keeping it outside while you're printing it, and then putting it back into the Mylar bag, right? So as I said before, Polymaker does a great job at offering a Mylar bag. That's also what MakerBot does with the spools. It comes with a desiccant in there, and it's a fairly straightforward process, right? So again, respooling the material, hoping that I didn't get any cross threading on the spool itself, making sure that I get the tip attached to one of the little anchor points, closing the zipper here in the Mylar bag, and trying to blow as much of the air out as possible, right? So again, the proper way to store the material, just keeping it inside of that Mylar bag, and making sure that it's as exposed as little as possible to any outside humidity. How do I set up parts when printing with polycarbonate? It's the same process, so you still are able to use MakerBot Print for slicing. And the only difference is that in slicing, you will select the Labs extruder, or if you're directly connected to the printer will automatically load and offer you the Labs extruder as the option that you're going to be printing with. What are some professional levels applications for these filaments? So PCFR, great for electronics, great for parts that might be exposed to higher temperatures. We've seen that also used a lot in transportation, just because sometimes you do need to offer some sort of proof that the material has some fire retardant properties. So we've seen that in trains, we've seen that in buses, public transportation, where you need to print replacement parts that have fire retardant properties to them. PolyLite, the translucent material, I'm not sure I've seen specific professional applications. I do, however, believe that it's a great material for some of the lighting fixtures, lighting applications. I think that that's how I would see it being used. And finally, the PC-PBT, that is great for specifically automotive. As I showed, we do have that rear view mirror, so applications that might be exposed to chemical wear, applications that might be exposed to the elements, that's where PC-PBT really shines. Is polycarbonate stronger than nylon carbon fiber? It's close, but it's not stronger. And that's a great segue for me to introduce and to invite you guys to join our second material showdown. So we're going to be printing new samples with the new materials that we have available for the method, and basically comparing, making a stress test and seeing which materials are stiffer, stronger, better, So, you know, if you guys want to join that, it's going to be, I think, next week. It's always exciting to get to destroy stuff, right? So we have like the actual jig or rig, allowing us to test the materials, stressing it out, just pulling from both ends of the materials, and basically doing just that, comparing the stiffness of the materials, and, you know, especially not only the stiffness, but how do they actually fail. Some materials might have more of a plastic deformation, and some materials might have more of a elastic deformation, crystal deformation, where they just shatter instead of like bending a little bit and then actually failing. And I think, okay, here's an interesting one. In the slicer, I can set a maximum of 90 degrees in the chamber. How can I get it to 110? That is actually, I'll say that question again, because that's one of the questions that I did have for our internal team, and one of the issues that we've been having and hearing a lot. In the slicer, I can set a maximum of 90 degrees for the chamber. How can I get it to 110? The answer that I got was that there's actually a bug there on the, well, it's not quite a bug, but on the readout of the printer, where you will set it up for 90 degrees, but the actual core temperature in the center of the chamber will go to 110. I think we do need to publish, you know, some more information about it and fix the slicer so that it actually offers you the 110 degrees. But it comes down to that. You're actually printing to 110, even though if the slicer itself maxes out at 90. There's a bug on the slicer software. The team is working on it, but you're absolutely right. Right now, when you try to slice it, it says it maxes out at 90. But that effectively gives you 110. On the core of the chamber. I'll talk to the team and see, you know, how can we better explain that and ultimately fix it so that you can get the proper settings in the printer. So with that, I think that's it for today. Thank you guys so much for joining us. It's always a pleasure. We're about to cross our 20th episode. Really excited for that. We might be getting some new stuff for that one, you know. Well, this was also kind of new, but in any case, you know, reach out, makerbot.com/chats, hello@MakerBot if you have questions, or if you have questions for me, you know, comments, feedback, things that you would like to hear more about. Felipe, Felipe, @makerbot.com, and we'll be happy to answer all of those. In the meantime, you know, happy printing. We hope to see you next time, and thank you for joining us today. Bye.